All right, I wanted to do a quick video to show you how you can use your graphing calculator to make this easy. We're talking about Newton's method here, and you probably knew that from the title because I will call this video something about that. Here's the problem we're looking at, and this is the example that I did in my Newton's method video, which is solve x cubed plus 3x plus 1 equals 0. In other words, we are trying to find the root of f of x equals x cubed plus 3x plus 1. Newton's method says that if I choose an initial value, which I will choose as -1, I can find subsequent values using this equation right here. And if you're not familiar with this, please go back and look at my Newton's method videos first. This is just a shortcut video on how to quickly do this process in the calculator. So here we go. Here's the calculator, and I've already preset my calculator screens a little bit. You'll notice that under Y1, I have gone ahead and typed in my function x cubed plus 3x plus 1. Under Y2, I'm going to put in the derivative. And if you use the Math 8 button in your calculator, it will pull up the screen you see before you. And I've left this open so that I can show you what to put in if you're not familiar with it. First off, we want the derivative with respect to x. Second off, we want the derivative with respect to x of the function. So I'm going to type in alpha f4, which allows me to choose the function y1. And because I want to not do it at a particular value, I want to do it at x equals x, which means it will do it at whatever value of x. And then you'll notice that under y3, I've plugged in Newton's equation, x minus the function divided by the derivative. So let's go back to our main screen. And what I'm going to do is I'm going to choose y3, but I'm going to plug in my initial value of y1. And this is a shortcut that you may or may not be aware of, that this will actually do the calculation for you. So this just calculated -1 minus the function at -1 divided by the derivative at -1. And it tells me that it is approximately -0.5 out to x number of decimal places. So Newton's method says to get x sub 1, well, excuse me, I've gotten x sub 1. To get x sub 2, I'm going to plug that back into the equation. So here's what I do. I again choose y3, but this time I'm going to tell it to use the answer from the previous problem. X sub 2 is -0.333333. Which is completely in, oh yes, no, that's what I did in the example. That's what I got, about a third. Now, here's the cool part. That's 0, 1, 2, that's x sub 2. To find x sub 3, all I have to do is tap enter. It will recalculate y of 3 using the previous answer. So there's x sub 4, x sub 5, x sub 6. You can see it converging. We're now converging to -0.32218535546. Notice that the last decimal hasn't changed. I now have an accuracy of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimal places of the root. And let's see, let's arrow up and calculate. So this was our 0, -1. This was our 1, x sub 2, x sub 3, x sub 4. My fifth iteration allows me to predict the root to an accuracy of 10 decimal places. And if I want to check myself, I could go to the graph. We see the root will, oh, it's going to plot, yeah, I didn't want to do that. It's going to plot y2 and y3 on there as well. And it's going to maybe take forever. So I'm going to shut this off. Oh, and it's frozen up because that is a long calculation. Okay, there we go. Let's bring it back again. We'll go to y equals. We will tell it not to graph the derivative and not to graph the Newton method equation. And we'll go back to our graph of y1, the function, and we'll use the calc feature to actually calculate this 0. Man, this is not reacting well. Here we go. And so I can arrow over to the left, arrow over to the right, and notice to 7 decimal places, my root is negative 0.3221854. So I got an accurate calculation, and I didn't have to do a whole bunch of crazy typing once I'd set it up by doing it once and then doing it a second with my initial value and then doing it a second time using the answer. I was able to just have it constantly reiterate until I was as accurate as I wanted to be. All right, outstanding. Well, thank you very much for watching. Hope you learned something.